Hi there. Welcome to the PowerShell DevOps and Cloud Conference. First of all, we want to thank all our sponsors. My name is Luc, and I'm very interested in coding and scripting. And today we want to talk about a specific subject about imperative and declarative coding.
And I'm Kyle Ruddy, and I am equally excited about coding, scripting, and all the things that come down to automation as we go through our session today called the Automation Showdown. So first we have a little bit of an agenda here going through kind of, a basic level set of some of the things, some of the lingo, some of the definitions that we're talking about. And then we dive right into the challenges as we try to manage a virtual machine within a vSphere environment. Then lastly, we end up with a kind of a thought process around where do we run some of these things. And then we end with a wrap up. So diving right into the definitions here, the most important ones here are the difference between imperative and declarative. And when it comes down to the imperative side, that's really the, how do I want to do something, the step-by-step instructions of performing a task. But then on the declarative side, it's a little bit of a change in the thought process, because now instead of going through that step-by-step process, you're telling a system what you want the end result to do and allowing that system to complete it. Then we get into kind of this notion of mutability. So when you're working with mutable objects, this is going to be something that's more or less centric around the imperative process. These objects that you're managing are changing and evolving over time. You can apply updates to them. You can troubleshoot them. They're in a constantly changing state versus the immutable side. And that's where the managed objects are really unchangeable, where these things are, constantly re-provisioned instead of being modified and updated. So it's also a little bit of a change in thought process there. And you're going to find immutable is a lot more focused on the declarative process. Then we get into the tooling itself. So for this, we have a comparison of a couple different tools, mainly PowerShell, different resources, Ansible, and Terraform. And the biggest thing to note here is PowerShell is going to be what we're using in these sets of challenges for the imperative side, and Terraform is what we're going to be using on the declarative side. And all of these tools really have, a little bit of a different process to achieve the same end results using the same different, parts and pieces underneath the covers.
After the theoretical overview of both methods, we're now going to dive into some coding examples to show you what exactly we mean with those imperative and declarative methods. Our demos will all be happening in the VMware environment, but what we're going to show you is just as valid in any other environment where you do coding. In the first challenge that we have here, we're going to tackle how you can create one or more virtual machines in your environment. So let's switch to the code view. Okay, this is a sample code that we can use to create a VM. As you can see, this code is already structured in a rather sequential way. I created several regions that will help me to develop this code to do what it is tasked to do. And there we see first a definition of a number of variables. The content is of no importance. It just serves to be an example here. Now, once we have those variables defined, we have to do some pre-configuration, things like creating your credentials, setting options for the language you are using. And in this case, I also use a stack where I can push and pop values later on in the code. This is the part where we actually connect to the server who is going to provide us and let us allow to create the VM. We do have some customization. We're going to use a template. So we create a new VM from a template, and there will be some customization done on that new clone, or whatever you want to call it, created from the template. Then we're going to say where that VM should be located. In VMware vSphere, they have the concept of resource pools. But since you can't use a long path, you have to go step by step, resource pool by resource pool, to arrive at the one where you actually want to locate the VM. And then we're going to actually create the VM. First of all, there's a cleanup code, part of the code that I included here. If the VM should already exist, we're going to throw it away. Mind you, this is not very safe. If this would be in a production environment, there would at least have to be a confirmation or a switch somewhere on your code that confirms that you can actually delete an existing copy. Now, once the machine that could have been there is gone, we can create our new VM. As you can see, I use splitting, which improves the readability of your code enormously. And then we're going to call the creation of the new VM. There are a few particularities on the new VM based on a template. One of them is that you can't set a network or a port group. So you will have to do that after you have created the VM. That's what we're doing here with those set network adapter commandlets. Now, once we created the VM, and which is good practice, we are cleaning up our environment. Now, if your code stops on PowerShell, it will normally be cleaned up automatically. But if you're doing this from an IDE, like we're doing here in Visual Studio Code, it is always good to throw away variables that you don't need anymore. One of them, for example, being those customization specifications that we created. And we also disconnect from the server. Now, let's run this code. So the machine has been created and is now being started. Let's switch to the web interface for that environment. We did create the VM in a nested set of resource pools, the three that you can see here. And this is our new machine that has been created and has been started. Now, after watching that first demo, we can already deduce some conclusions here. First of all, our code was sequential. There was some branching in there, by which I mean the if then else's, eventually some do whiles or some switch case instructions, but in concept, the code that you're writing in this imperative method is sequential. We're starting at line 1 and following a path through our code, we end with the last line of our code. That means that you're the driver of the vehicle here. You're the one who decides how the logic in your code flows. If there is a test to be done, remember when we cleaned up the old VM, if it should still exist, that is a test that you will code or add to your code and which takes action depending on the outcome of that test. So that means you have to provide everything. You have to foresee everything. Now, the code that we showed is not completely user-friendly in that it doesn't have all the error handling that you should normally have in a production level code. But this is only a sample code that we showed as a demo. Now, is this code reusable? Yes, it is. You can reuse it. But as you looked at the code, there is some logic in there that probably I understand since I wrote it, and perhaps already in 6 months' time I will have difficulties remembering why some parts are in there. So if you want to make this reusable, you have to introduce a certain formalism. You have to capture that or package that code in functions. The functions, even in a module, you have to add help files. So the code, even if it is imperative, can be made reusable. To go one step further, let's have a look at our second demo, where we're going to take some of those formalisms that we discussed just a minute ago and take it one step further and try to create more than one VM in a similar way. In the second example or demo code, you can see that the layout of the code, if you look from a high level, is changed. We have packaged a lot of the functionality that we also had in the previous example in separate functions. This is already one step towards making this code reusable by others, by your peers, or even by people in the whole wild world. Now, if we package it in functions, that means that our main code becomes quite simple. If you look at the preamble here, this file we will have a look at in a minute. So we call a function where we do a lot of the things that we had earlier on in the first example. We set Power CLI configuration, for example, and we also create some credentials and we connect to our vCenter in this case. Now, this file here, that is a change from the previous example. What we're doing here is, okay, and I used a JSON file, but this can be whatever data format that you prefer, that you can read and write from PowerShell. So in this case, JSON was my language or format of choice. So you can see there are two sections in there. I have a global one where I keep data that is globally applicable to my code that I'm going to use. This contains things like the timeout, but also the name of the vCenter to which we are connecting and the user. Now, this is a newer thing here. Let me minimize this so you can see it better. I also introduced scaling in this example by providing data for more than one VM. So if you look at the first VM, this resembles what we had in variables. Remember the first region in the first demo? But now we repeat this, and we do this for 2 or more VMs. So we can have a number of VMs in this JSON file, which are all going to be created by the code that we're going to look at here. So that's what this JSON file is doing. We're reading it into a data object inside your PowerShell session, and then we actually come to the code that will create those VMs. Now in this case, this is very straightforward. That is one advantage of using functions and layering your code in such a way. You have one simple main loop here. We're going to run through all those VMs. Remember 2 in our example JSON file. And we're going to create each of these VMs in a sequential way. That's what the for each object loop is doing here. Now let's run this example, and we will in fact see the same thing that we saw. Now we can already switch to the web client where we can see what is happening in that environment. And as you can see here, the first one is currently being cloned. You see that there's a second machine that entered that same resource pool group that we had earlier. Once it is fully created, he's going to power it on. Okay, both VMs have now been created and have been started. We could, in our JSON file, have included X number of VMs, which would have all been created in sequence by our code. After that second imperative demo, there are a few things we can conclude here. First of all, scaling is possible. As you can, or as you have seen in the JSON file, we could have added X number of VMs, and we could have created all those with the same code. Now, the fact that we're using a separate JSON file and a PS1 file to create the VMs, that is one important concept here, where you separate your code from your data. This will become more obvious once we go to the declarative method, as you will see later on. And all this code data separation is one of the basic concepts in a DevOps environment. Since you have your code and your data separate, you can add both of those under source control. And a change to your data doesn't necessarily mean that you need to change your code, and vice versa.
So now we're going to transition over to the declarative way of creating a virtual machine, in this case using Terraform. So here we have a couple different blocks of code that have been established within our configuration file here. The most important one is up at the top, telling Terraform exactly what provider that we need to work with. This is very similar to saying like a module from the PowerShell gallery. Then we have our provider block that tells our vSphere provider how to interact with our vSphere environment. And then from there, we get into the point of establishing some different objects using what's known as data resources. These are, for all intents and purposes, read-only objects that Terraform now knows about and understands, such as our data centers, such as our data stores, and our resource pools, and so on, that all basically make up a virtual machine. Then we get down here to the bottom, and this is where it starts to get important here. And here is where we are establishing the template that we want to make use of in order to clone to make our virtual machine. Then dropping into our resource block here, resources are what Terraform uses to manage. So, this is something that Terraform knows about, understands, modifies, and controls the entire life cycle of this system. So we do some of the basic stuff like name, resource pool, data store folder, where it lives, what it runs, so on. Then we start making use of that data resource from the template in order to tell this virtual machine to have the same number of CPUs, same memory, same SCSI interface, the same disk configuration. And then towards the bottom here is our clone block, where we're going to tell this Linux system that we're cloning it from that template, and we want to have it update the host name, domain, and have the network interface pull information from DHCP. Then we also have what's known as a variables file. And this is kind of establishing what the variables that our configuration file uses. So we can see some things here, such as the vSphere server, where our resource pool lives, what the vSphere network is, even the virtual machine name. All of these different things are established as part of this variables file. So now that we have kind of an understanding of what all of this looks like, we are ready to go ahead and run through our example. So if we go ahead and open up our terminal session here, the very first thing that we want to do is a Terraform init. This is telling Terraform to download and make accessible all of those things that we created as part of our configuration, including our vSphere provider that it grabbed from the Terraform registry. So now we're going to do a Terraform plan. This is where Terraform takes that configuration and evaluates what it needs to do in order to go from, what's there, what it knows about, into what it needs to create, into, that design phase of how it performs all of these tasks. So we can see some of the things in here that we didn't specify as part of the configuration file. So this is where it gets really important to understand what the defaults are for some of these things, or to go back in and to appropriately set them. Then here at the bottom, we're running a Terraform apply. This is going to take the output from that plan phase and then apply it to our vSphere configuration, or to our vSphere environment. So we told it, yes, go ahead and plan that and apply. And now if we look in our vSphere environment here, we can see our PDCConf resource pool. Within there, we have our brand new virtual machine. And we can see some things off into the tasks there, such as the clone, configure the virtual machine, customize it, and then power it on there at the end. Then here, after a couple seconds, after it runs through its entire process, we should hopefully see that the important things, such as the DNS name and the IP address, show up so that you can see that it's unique and show that it went through that clone process to establish it as a unique resource within our vSphere environment. All right, there we go. DNS name has been updated to what we configured in our variables file. Now we have an IP address, so we are all set and ready to go with this virtual machine. And if we skip back over to our vSphere, the output from our Terraform environment there, we can see the process that it went through to create that virtual machine and some of the outputs that we configured there as well, so that we know what the MoRef ID is, because that's extremely important when using the vSphere provider, as well as some other pertinent information, such as the guest tools are in the running state. So kind of to wrap that up, some important parts there. Moving from imperative to declarative, here you are the designer. You control what the design is of the of the object that's being managed, in this case, a virtual machine, and you let Terraform, again, in this example, do all of the work to get it to that end result. So you have to understand those defaults, but yet still define the custom values that you need to modify in order to create that object. It's reusable just as much as the imperative side is, but there are some additional requirements, such as additional definitions or even file structures if we needed to move further to create additional virtual machines, but we'll get into that here in just a second.
In our second challenge, we're going to do a very straightforward and simple thing. We're going to create a snapshot of one or more VMs. The idea behind this challenge is that even simple things are best done by following some concepts and guidelines that you also use for complex things. Let's have a look at the demo here. As you notice, we're using the same concept that we used with the creation of VMs here in our code. We're packaging logic or code that belongs together in separate functions, which can be used later on for reusability in a module or to pass through your peers. And the main code is quite straightforward in this case. We are reading again from a JSON file, like we did with the create VMs. And then, with the data that we obtained from that JSON file, in a loop, we are going to create a number of snapshots on one or more VMs. Now, let's have a look at that JSON file in this case. Again, the layout is somewhat similar to the one that we used to create VMs. We have a global part where we have things like the name of the vCenter, but also some actions that Power CLI should take when, for example, there is no valid certificate on that vCenter. Then we have data that will determine how our snapshots will be taken. On VMware, there are a number of options when you take a snapshot. For example, you can quiesce the guest OS of the VM that you're snapshotting, which makes it more reliable to reuse as a start for a new VM. You can also, and this is only valid for VMs that are powered on, take the memory, include the memory in your snapshot, which would allow you to start exactly after the snapshot was taken. And then we have, of course, just like we had in the previous sample, we have a section with VMs. In this case, it's just names of VMs on which we are going to take snapshots. Again, in our example, there are two, but we could easily expand this to X number of VMs. Now, let's go back to our code. Again, the getMyValues function is quite straightforward. It's just reading that JSON file and converting it to a PowerShell object. The preamble thing function is connecting to our vCenter, setting some Power CLI configurations, and catching eventually errors when the connection to the vCenter won't work. So again, this is rather straightforward. And as you can see here, he is currently taking the snapshot of that first VM. Okay, the first snapshot has been taken. He's now busy with the second one. We can have a look at how that snapshot looks on that first one. So as you can see, there is some information that we have that belongs to the snapshot, the name of the user that took it, but also there are those two options that we specified. There is a description. So that was part, if we go back to our JSON data here, that was part of that snapshot section in our JSON file. There aren't that many takeaways from that previous demo with the snapshots, but there is one that I think is quite important. Even if your code is not complex, the snapshot code was very straightforward and very simple. That doesn't mean that you should drop some of your coding concepts. Remember, we still had separate functions for separate functionality in our script, and we separated the code from the data. So even if you have a very straightforward script or code, it is easy to write it all in one file, but try to keep those concepts that you have been using also for more complex scripts and apply them to your simple scripts. And again, this is a repeat from the previous demo. Separate your code from your data. This will allow source control. You can change code without affecting your data. You can change data without affecting your code. All that reminds you, or should remind you, of DevOps concepts that you should be applying in your environment.
So again, we're going to make that switch from the imperative process over to the declarative process. So in order to manage a snapshot for a virtual machine, so in this case, we have just a brand new resource block that's of a type virtual machine snapshot. And there's a couple bits of information that we need to know and understand for this, such as the UUID that we can pull from that virtual machine that we already created. Then we can give it some additional information, such as the name, description, whether or not we want to snapshot the memory or quiesce the underlying file system. So again, we have the very same process of going through, doing a Terraform plan. You can see that it's not going to make any changes to that prior setting or area. And then we get into the create for the actual snapshot itself. So we have that one new resource to add. We can just hit Terraform apply. This time we're going to do the auto approve, so it goes straight through the plan output into the apply. And if we skip over to our vSphere environment here, we can see that the create virtual machine snapshot is there running and applying that the creation of that snapshot. But then what happens if we need to create additional snapshots in order to, we made some changes, we made some updates. So now we need to go ahead and do another snapshot. So what's the process there? So thanks to the declarative manner, all we need to do is take this resource block and copy it again, and then give it a new name. So we're going to change our VM snap name of this resource over to VM snap new, give it a new snapshot name that's part of the, vCenter object snapshot name, and then we're all set, ready to roll again. So all we need to do is then do our plan and apply process again. We're skipping directly to the apply phase because we know what the plan is going to look like. And again, we're not making any changes. We're not destroying that prior snapshot. We're just doing that one additional snapshot. On the vCenter UI side, snapshot creation process rolling right through. And so just like that, as easy as possible, we've created 2 snapshots now. Now, if we want to kind of complete the life cycle of our snapshots, we can go back through to our configuration file that's here. And all we need to do is delete the declarations for those snapshots. So now we've removed those, the definition of those 2 snapshots. We just need to run the Terraform plan and apply phase again. The output, since we're making a change this time, in all actuality, we're doing a destroy. So we have 2 objects that we're destroying, those 2 snapshots. Then if we go back to our vSphere environment, we can see that both of those snapshots have been removed. vSphere and Terraform took care of the order in which case those snapshots are removed, so we didn't have to worry about any type of inheritance or hierarchy in between the two. And Terraform does all of that work and magic for us. Makes it really simple and straightforward. So there, we kind of took the existing configuration from our first example and we build it out so that we can kind of tell, we can have a notion or a concept of all the related items going back to that one individual virtual machine so that we have the entire story for that system. And using source control continues to build on that history so that, if we look at the configuration now, we don't know that there were snapshots that were ever there. But if we go back to source control, we know that they were there, created, and then eventually removed. But Terraform just knows what the existence of that object at this point in time right now.
For the third challenge in our session, we're going to look at removing a virtual machine. So if you look at the two previous ones, we're definitely looking at the life cycle management of virtual machines. We created one, we took snapshots. Now we're going to actually remove a VM when it is not needed anymore. And for that, let's have a look at a short demo. In this demo, we're again using the same concept. We separated some of the logic in separate functions, and we're using a JSON file to provide the data to our code. But in this case, we're going to look in a bit more detail at some of the features of this code. First of all, there's the preamble function that we used multiple times before. But I want to draw your attention to this try-catch construct that we have here. So in fact, what we're doing here in this code, we're connecting to our vCenter, which is the management system for our virtual environment. Now, if things go wrong, the rest of our code probably will not work since we're not connected to that vCenter. Now, you can do a lot of if-then-else's in there, but the easiest way, in my opinion, is to use a try-catch construction. And if you have an exception on one of those commandlets that you execute in your try block, the code will automatically jump to your catch block. And in there, as you can see here, you can include the throw statement, which will end your execution and provide some additional information to the user of your code. Now, some errors on some commandlets don't necessarily throw a stopping, a terminating exception. In that case, you can always add an error action stop to a commandlet. Most modern or recent commandlets have that option for the error action. So if the commandlet, an error in the commandlet does not throw a terminating exception, force one by doing an error action stop in there. That's about the try catch. Now let's have a look at the data, and it resembles a lot the data that we used, structure that we used for our snapshots of VMs. Again, we have a global section in there with the name of the vCenter and so on. We have a remove. On the remove VM commandlet, there are a number of options there, and we provide those in here for all the removes that we're going to do in our code. The run async is an interesting one. If you work with PowerCLI, it will start your remove task in the background. So your script will come back immediately, and the remove will continue in the background on your vCenter. And then, of course, we have the VMs, the two that we created in our first demo, and of which we took a snapshot in our second demo. We're going to remove them now with the code from our third challenge. The main structure of our code is not that difficult. We again have that JSON file where we will now run through the VM section, and for each of those VMs, we'll get the VM, we will stop it, because we can't remove a VM if it's not powered off, and then we will remove it using those settings, delete permanently and run async, that we also specified in the global section in our JSON file. Another thing that I want to point out here, and you should have noticed by now, that I'm a big fan of splitting in PowerShell. I could have done all these parameters just behind the remove VM commandlet, but it would be a very long line and hard to read on a screen. So for legibility, but also for clarity of your code, I strongly suggest to be using splitting in all your future code. Now let's have a look and run this web client of our vCenter immediately. As you noticed, our command or script was done rather quickly, while those commandlets, the tasks in the background, were still running. Okay, by now they're both completed. And as you can see here in our resource pool, both VMs are gone. They are removed. There aren't that many takeaways in this challenge, but like I mentioned during the review of the code, there are two things that I think are important. So on a side note, I do love splatting, and as you have seen in all the code that I've shown you, it makes that code a lot more illegible than if you would code everything on one line, all these parameters after the same commandlet. And another thing that I think is quite important to know how to use and to use it at the correct places is the try-catch construct. It allows you to capture error handling in a straightforward way and provide sufficient information why a specific commandlet failed.
So on the declarative side, we're going to switch over and complete the life cycle of this virtual machine by removing it. However, instead of, like we did with our snapshots, just removing that resource block, which theoretically would work, we're going to make use of a new option for Terraform called Terraform Destroy. So here, if we scroll back up after running that Terraform Destroy command, we can see that it's changing all of these resources over and marking them as null and removing it from our vSphere environment. So all we have to do is enter in yes, very similar to the Terraform apply process. And then Terraform will go through to our vSphere environment. It will initiate that guest OS shutdown, and then it will remove our virtual machine from the inventory. So just like that, Terraform takes care of that entire process for us so that we don't have to think through it. So when it comes to the declarative side, a lot of these dependencies are managed for you on your behalf because, again, you are the designer, and Terraform, or the declarative means, are going to understand what those dependencies are and do it and manage it and perform it for you.
For challenge 4, we look at VM lifecycle management at scale. What we mean by that, instead of doing coding on 1, 2, or a few VMs, we're now looking at scaling, where we can do 10, 100, 1,000 VMs. As we have seen in one of the previous demos, you can easily do that by separating your code and your data. If you look at the second demo in challenge 1, where I rearranged my code and extracted all the data in a separate JSON file. Now, that is a basic example of how you can scale your code and your data. So have a revisit of that demo.
So when it comes to managing your virtual machines at scale, or really anything at scale, using declarative means, there's a couple different ways that you can do it. You could create separate resource blocks. You could create several different directories with each with their own individual configurations. You could use workspaces to separate them out. However, the one thing that I find the easiest and applies the most consistent logic is the usage of modules, especially when it comes to Terraform. So here we have our updated configuration, still have that Terraform block, still have that vSphere block, but then we get to the module, and this is where we're describing what we want our end result to be again. However, it's so condensed compared to what we've seen in our past declarative experiences. So here we have that source, and this points out to where our module lives, and it's called VM at scale. That's where we define what our virtual machine looks like. Then we can make use of functions such as count, so we can create multiple virtual machines as part of this. We can give it names and specific names built on what that count process is going, and even update certain things like our template. So then if we roll over to our variables, this is also condensed. So we have our virtual machine count variable, as well as our prefix and our template name that's been added there. Then if we jump over to our module that's over there, we have our main configuration file. And this is going to look exactly the same thing as what we've seen in the past. However, now we can reuse this module so that we don't have to, include that entire block of code every single time. And the same thing there with our variables file, that contains all of the exact same information as well. So now if we jump back to our main configuration file, we are ready to let this roll. Opening up our terminal, all we need to do is another Terraform init, because in this case, it also needs to kind of obtain information about that module. So there at the top, you can see the initializing modules stage. And then we get into the provider plugins, which is exactly what we saw in the past as well. Now we're ready to go ahead and perform our Terraform plan. And at this point, it's going to build out the plan on how we go from whatever Terraform knows about now, which is nothing, into 4 different virtual machines. Here we can see kind of the build out of how Terraform creates and understands that plan. And we can now hit our Terraform apply and let that roll. So there we see the output from our plan process again, and then it jumps right into paralleled creation and cloning of these virtual machines. So now if we look at our PDCConf resource pool there, we can see different made by Terraform VMs because that was the prefix that we assigned it, as well as our number there at the end. So these are all being powered on, cloned, and customized as well. So each of these are going to have updated DNS names and unique IP addresses as well. So if you give it just a second, as you see that console screen start updating, there's our guest OS. We have our updated DNS name, have our updated IP address. Then if we jump down to the next one, we can see that this one also has Terraform 01 as its unique name. And then we can jump through to the rest of them to see that exact same situation where Terraform was able to do that, parallel at the same time without really having to do much on our part, just define that in our configuration file. So at this point, now we want to go ahead and we want to clean this up. So maybe we've created these resources and we only need them for a short period of time. So now we're ready to remove them. We can go back through and do a Terraform Destroy. This is again going to give us that plan output saying that we're going to take all of these resources, these 4 resources, and we're now going to destroy them. So all we need to do now is enter in yes, and Terraform is going to go through the process that we saw earlier in our last challenge, challenge 3, in initiating the guest OS shutdown and then removing them from inventory and deleting them from disk. So we can start seeing those get removed from our inventory. All of it takes a second because Terraform is going to be continually polling and viewing the state of those objects to make sure that they're shut down, make sure that they're to the point of being able to be removed before we get to the end of our process there, so that we can see that the destroy was complete. We have removed those 4 different virtual machines. So that was a brief look at how you can use declarative means to really scale everything out. And it's really even furthermore easier to do that when everything is following that consistent means, which adds incredible consistency across the board so that every single item that's been deployed using the declarative means is going to have that same exact end result that's known as item potency. And modules even take this a step further to make the deployment simpler. So, instead of going back to challenge 1 where you had that huge block of code, you can use a module to really consolidate that down and allow other folks to then also consume it without having to really be well-versed in either the vSphere module or the vSphere provider or creating things within a vSphere environment.
Now that we've seen all these methods in imperative and declarative, it raises the question, where should I run all these scripts? So where to run these? Can you run them on your own workstation? Of course you can, but is that the ideal environment to run such sometimes very long-running scripts? Definitely not, because your workstation is used for daily work, office work. It's not intended to be a runtime server. Do you install a dedicated server where you run all this? Now, a dedicated server implies maintenance, implies additional hardware required. So in the end, that is not really the ideal solution. So what we ideally would want is a throwaway box, meaning a server where we can run our scripts, and once we are done with running our scripts, we just throw that server away. Now, this, in my opinion, is the ideal solution to run your scripts. Not those one-off administrative scripts, but your long-running scripts that you run on a regular interval. They should ideally be run on a throwaway box. A funny side remark here, you've heard probably that expression, don't treat your servers as pets, but treat them as cattle. This pets versus cattle analogy is older than most of us know and think. In fact, this comes from a presentation by Bill Baker, Microsoft manager, scaling SQL Server, and it dates already back to 2006. Now, let's have a demo and look at a possible solution. One possible solution for a throwaway server is something that VMware currently offers, and is called the Script Runtime Service for vSphere, in short, SRS. This is Kubernetes based, and it provides a REST API to interface with it. Schematically, it is quite simple. You have your user, you have a REST API, you call that SRS service running on a dedicated VM. By default, it comes with PowerCLI and you address a vSphere environment, but nothing prohibits you from installing any PowerShell module on that server and address any target platform. But to make this a bit more clearer, let's have a look at the demo. Our first demo script is a very standard sequential script like we normally execute all our scripts. First of all, there are a number of help functions. The one that we use here is the invoke SRS method, which is nothing more than a wrapper around an invoke web request, which does the actual REST API calls. Then we have a bit of preamble where we're going to resolve the host into a fully qualified domain name, and we're going to set up the headers for our REST API calls. Like any REST API, you first have to log on. That's what this part takes care of. Then the SRS is based on run spaces, so we have to create a run space before we can actually run a script. We have to wait a bit till the SRS server tells us that he's ready, and then we're going to execute our script. In this case, what I'm using is a script block with a very straightforward two commandlets in there. I'm getting a cluster and I'm getting all the VMs in that cluster. Now we use this script block and convert it into a string to be passed to the REST API server. Then we run the script, and then we have to wait till the SRS server indicates that the script is done running. Once it's done, we retrieve the output. We retrieve the other output streams like error, warning, debug, and so on. And we clean up after ourselves. We remove the run space that we created earlier, and we log out from the SRS server. Now, let's have a look and run this. And there you have it, the result, all the VMs in that cluster. So this is a very straightforward way to run PowerCLI scripts. We didn't run anything on our current workstation. Everything was run on that remote SRS server. That first example did work, but it had a serious flaw. We had to include the code in the actual script. So what happens if we have a number of scripts already laying around that we want to use and execute in that similar fashion versus the SRS server? Let's have a look at this rather straightforward statistical script. It obtains from all the VMs in that cluster a number of performance metrics and returns them. Now, if we want to run those existing scripts, we have to somewhat rearrange our original script. What we have here is we have created a function invoke SRS script, which, if we open it, contains all those regions that we saw in the previous script, but now bundled into one function. which makes it a lot easier for people to use it. The function itself is again the same as what we saw earlier, and we just have to call this invoked as our script, and we're going to read in the sample from that location where we have the original file. Now, just let's have a look at this, how we run it. As you can see, we have all that data being returned to us as if we would have run this on our own workstation. And now, instead of making an invoked SRS script function and copying that each time, the next step would of course be to package that in a module and make that available company-wide, or even ultimately post it on the PowerShell module gallery.
I don't know. Do I need to do an intro into yours, or can we just
No, just start playing it. That should be enough.
Okay.
I think I start in any case in this first challenge or something like that, so they know what we. And I'll show the slides. Do we do the wrap up immediately, or?
Yeah, we can just jump into the wrap up.
Right, then I'm going to pick up the slide here on the left that I see what.
Yeah, so you're the first one, I'm the second two, then you, and then I end with version control, right?
Okay. So the moment you click and the line comes on the screen, I'll start. Our session has a number of takeaways in our opinion. So the first one, as we already mentioned, the imperative method that puts you in the driver's seat. You decide where the car is going.
And then on the declarative side, this really puts you into the thought process of being a designer and trying to tell a system exactly what you intend that object to be. But really, when it all comes down to it, use what works best for you, your situation, and your environment, because a lot of these things might change depending upon who all is working within your environment.
One thing that we think is very important is that you should separate your code and your data. So you can change code, you can change data without one impacting the other.
And lastly, version control. If you're not using it today, regardless of whether you're using imperative or declarative tooling, please use it. Please get a little oriented into the usage behind Git-based repositories to save and store your code, to have that history along the way as well. Thank you.
Thank you.
Awesome.
How are we on time with that recording? Because